October 12th, 2015. The sea is dark, restless, and unforgiving. A lone littoral combat ship cuts through waves off the coast of Southeast Asia, its hull groaning under the strain. Engines sputter, water jets struggle, and alarms flicker in the dim glow of the bridge. Inside, the skeleton crew fights to keep the vessel moving. 40 sailors tasked with controlling a warship designed for 85. They push buttons, check gauges, but nothing feels reliable. The ship was supposed to be fast, modular, revolutionary, a Swiss Army knife in the sea. Yet, here it drifts, a symbol of ambition colliding with reality. Outside, the wind lashes the aluminum superstructure, and spray smashes against the deck. Every bolt, every seam, every system is tested against nature and the limits of design. Somewhere below, engines cough and whine, the combining gear straining to deliver power it may never reliably provide. On shore, naval planners and politicians chart schedules and budgets, unaware, or perhaps unwilling to acknowledge, the fragility of the vessels they commissioned. Billions of dollars, decades of work, and still, in the middle of the Pacific, one ship fights simply to stay afloat. This is the story of the Littoral Combat Ships, the Navy's bold experiment that promised a new age of maritime dominance, but delivered chaos, cost, and controversy. And it begins here, with a ship at sea, struggling against the very water it was built to command. Next, we explore the context and background that led to the creation of these ships. At the turn of the 21st century, the U.S. Navy faced a shifting strategic landscape. The Cold War had ended, but threats remained unpredictable. Terrorism, regional conflicts, and asymmetric warfare were reshaping naval priorities. Traditional blue water dominance, clashes between aircraft carriers and battleships, was no longer the sole focus. Instead, planners envisioned a fleet that could operate near coastlines, support expeditionary forces, and respond quickly to emerging threats in littoral zones, the shallow waters along shorelines where conventional vessels struggled to maneuver. In 2001, the Navy introduced the Littoral Combat Ship, LCS, program, an ambitious initiative designed to field fast, modular vessels capable of multiple mission profiles. The concept was straightforward in theory. A single platform could be fitted with interchangeable mission modules to conduct surface warfare, anti-submarine operations, and mine countermeasures. By swapping out systems, the Navy could maintain operational flexibility while reducing the need for specialized vessels. Two distinct designs emerged. The Freedom class, a monohull constructed in Marinette, Wisconsin, and the Independence class, a trimaran built by Austal USA in Mobile, Alabama. Each design reflected different philosophies: speed versus stability, steel versus aluminum, traditional hull versus modern trimaran. The Navy intended to leverage competition between the two to optimize performance. In practice, the differences would create logistical headaches, incompatible systems, and increase costs. Originally, the LCS was part of a broader goal: a 355-ship Navy, as outlined in early 2000 strategic plans. This figure included surface combatants, carriers, submarines, and patrol vessels. Littoral combat ships were intended to replace aging frigates and minesweepers, forming a small surface combatant backbone. Analysts argued these ships would be relatively inexpensive, quick to produce, and adaptable. Yet from the outset, critics warned of technical complexity, underestimated costs, and unproven modularity. Congressional oversight followed closely. Reports highlighted challenges in propulsion systems, crew size, survivability, and weapon integration. In the Freedom class, a combining gear designed to unite diesel and gas turbine engines proved prone to failure. The Independence class, built with aluminum, was vulnerable in high sea states. Both designs demanded skilled crews, yet the ships were meant to operate with minimal personnel, creating tension between operational requirements and human capacity. Despite warnings, political pressure and industrial considerations drove continued production. Senators and representatives from districts housing shipyards championed the LCS program, citing economic benefits and local jobs. In parallel, Navy leadership pressed forward, eager to field modern vessels even as testing revealed gaps in mission capability. By 2008, the first LCS was launched, carrying the weight of expectation, innovation, and risk. The stage was set. A fleet of ships designed to transform naval operations was entering service before modular systems were perfected. Ambitious timelines, competing designs, and complex technology collided with reality. For the crews, this meant operating vessels that were revolutionary in concept, but fragile in execution. Next, we will continue with context/background, Section 2, examining the unfolding technical and operational challenges that define the early years of the LCS program. As the Littoral Combat Ships entered service, early deployments revealed the gap between design aspirations and operational reality. The Navy had envisioned vessels capable of sailing at speeds exceeding 40 knots, outpacing conventional warships, and executing modular mission profiles in nearshore environments. Yet this pursuit of speed and flexibility came at a cost: reduced range, limited weapon space, and heightened maintenance demands. Fuel consumption quickly emerged as a significant constraint. Operating at high speeds required enormous energy output, leaving less room for mission systems, supplies, or extended deployments. The trimaran hull of the Independence class offered stability and speed, but aluminum construction made it susceptible to structural stress in high seas. Conversely, the Freedom-class monohull, while more traditional, suffered repeated failures in its combining gear, a complex mechanism linking diesel engines and gas turbines to the ship's water jets. Both designs demanded specialized knowledge from the crew and contractor support for repairs, complicating routine operations. Another persistent challenge involved the modular mission packages themselves. These systems, intended to allow rapid role changes from mine countermeasures to anti-submarine warfare or surface combat, were delayed and underdeveloped. Some modules failed entirely. Others were incompatible with the vessel's sensors and propulsion noise. For example, the towed sonar system for anti-submarine missions produced inaccurate readings due to interference from the ship's wake and engine vibrations. Mine countermeasure modules, critical for safe navigation in littoral waters, were still being refined years after initial deployment. Crew size and readiness became another pressure point. Unlike traditional Navy ships with crews numbering in the hundreds, LCS vessels were designed for small teams of 40 to 50 sailors. In practice, this was insufficient to operate, maintain, and troubleshoot the advanced systems on board. Ships frequently required contractor assistance for even minor repairs, a reliance that slowed deployment and created operational vulnerability. Sailors often spent more time repairing the ships than conducting missions, eroding morale and confidence. Political and industrial factors further influenced the program. Shipyards in Wisconsin and Alabama received priority, creating pressure to continue production even as deficiencies surfaced. Congressional support remained strong, with leaders citing economic benefits, local employment, and the strategic promise of the LCS program. Critics, including former Navy officials and independent analysts, warned that quantity was being prioritized over quality. Cost overruns mounted, with each ship exceeding initial estimates by hundreds of millions of dollars, and the Navy faced scrutiny over the projected $100 billion lifetime cost of the fleet. Despite these issues, the LCS remained a centerpiece of U.S. naval modernization plans. Deployments to the Pacific and Mediterranean offered mixed results. Crews faced mechanical failures, mission limitations, and the constant tension of operating vessels that had yet to demonstrate full combat effectiveness. Yet the promise of a fast, flexible, and modular surface fleet kept the program alive, illustrating the complex interplay of ambition, technology, and politics in modern naval procurement. With this context established, we now turn to the Angles section, where the story of the LCS program is examined through human, tactical, technological, and leadership perspectives. Life aboard a littoral combat ship was a constant test of endurance and adaptability. With crews smaller than traditional Navy vessels, sailors faced demanding schedules, often juggling operational duties with maintenance tasks that normally required specialized technicians. The tight quarters intensified stress. Hot bunking, shared facilities, and long hours created a unique culture of resilience. Yet morale was strained when systems repeatedly failed during deployments, forcing crews to rely on contractor intervention for repairs. A sailor aboard the USS Freedom recalled spending weeks troubleshooting propulsion issues that, on larger ships, would have been managed by dedicated engineering teams. For the young officers tasked with command, every decision carried amplified consequences. A single mechanical failure could compromise an entire mission, reflecting directly on leadership evaluations and career progression. The human cost was immediate and tangible, shaping the lived experience of the LCS program. Technological angle, modular mission packages, and propulsion systems. The technological promise of the LCS lay in its modular mission packages, designed to transform a single hull from a mine countermeasure ship to an anti-submarine hunter or surface combatant. These modules represented a bold step in naval innovation. In practice, the modules suffered from delayed development, integration issues, and mechanical incompatibilities. The towed sonar for anti-submarine operations, for instance, was hindered by interference from the ship's wake, while mine-clearing systems remained partially fielded years after commissioning. Propulsion also posed significant challenges. The Freedom-class monohull relied on a combining gear system to synchronize diesel and gas turbines, frequently breaking down under operational strain. The Independence-class trimaran used a different approach, linking engines to separate water jets, but the aluminum hull proved vulnerable to high seas, causing structural stress. Technological ambition collided with engineering reality, highlighting the difficulty of innovating within budget and time constraints. Tactical angle, speed versus combat effectiveness. LCS vessels were conceived to operate close to shore, where speed and maneuverability would compensate for lighter armament. Their design prioritized high velocity, over 40 knots in ideal conditions, enabling rapid response and repositioning. Yet this speed came at the expense of weapons, range, and endurance. Limited deck space restricted heavy armament installation, while fuel consumption curtailed operational range. Anti-submarine and mine-hunting capabilities were compromised, leaving the ships vulnerable in contested environments. Tactical exercises revealed that the LCS could quickly traverse littoral zones, but lacked the resilience to sustain prolonged engagements against enemy destroyers or missile-equipped surface combatants. The ships were fast, yes, but the very attribute that defined their tactical niche also constrained their strategic utility.
Leadership angle, command pressure, and decision-making. Top Navy leadership faced a delicate balance between political expectations and operational realities. Secretaries of the Navy and admirals repeatedly pressured subordinates to deploy ships even when they were not fully mission-ready. During exercises in the Asia-Pacific region, commanders pushed LCS crews into missions despite known propulsion issues and incomplete mission modules. This emphasis on appearances over readiness reflected the desire to meet congressional expectations for fleet size and visibility. Young officers, eager to advance in their careers, often complied, navigating a landscape where failure could be career-limiting. The pressure to demonstrate capability in the field, despite persistent technical shortcomings, illustrates how leadership choices reverberated through the ranks, affecting both morale and operational outcomes. Political angle, congressional influence, and shipyard interests. The LCS program was shaped as much by politics as by naval strategy. Shipbuilding contracts were distributed across multiple states to satisfy local economic interests, leading to competing ship classes. The Freedom class for Marinette Wisconsin, and the Independence-class from Mobile, Alabama. Lawmakers representing these districts actively advocated for the continuation and expansion of production, sometimes in opposition to critical voices like Senator John McCain, who repeatedly labeled the program a boondoggle. Political pressure helped secure funding, maintain workforce continuity at shipyards, and justify procurement despite systemic technical and operational issues. The resulting program became a compromise between engineering efficiency and political expediency, illustrating the intricate interplay between governance and military procurement. Enemy angle, operational vulnerabilities. From the perspective of potential adversaries, the LCS presented a unique combination of speed and fragility. Lightly armored, with limited anti-submarine and mine warfare capabilities, the vessels were vulnerable in high-threat environments. Enemy planners could exploit propulsion dependencies, gaps in mission module functionality, and limited defensive armament. While the Navy envisioned LCS deployment in low-intensity littoral zones, the vessel's operational constraints reduced their deterrent value against near-peer adversaries equipped with modern guided missiles and robust naval assets. The very design intended to create a versatile, rapid response platform inadvertently highlighted strategic vulnerabilities, underscoring the challenge of aligning innovative naval concepts with real-world threats. Breaking point: high-profile failures at sea. By late 2015, the Littoral Combat Ship program reached a critical juncture. Operational deployments exposed the full extent of design and maintenance shortcomings. On the Freedom-class vessels, the combining gear, responsible for merging diesel and gas turbine power to achieve top speeds, began to fail catastrophically. Engines suffered repeated breakdowns, forcing ships to limp back to port or be towed entirely. The Independence-class trimarans, constructed with lightweight aluminum hulls, cracked under stresses imposed by high-speed operations in moderate seas. Water jet propulsion, designed for rapid maneuvering, created control challenges, resulting in collisions with docks and canal infrastructure. Each failure amplified scrutiny, embarrassing Navy leadership, and prompting urgent congressional inquiries. Mission module failures. A core promise of the LCS program was modularity, interchangeable mission packages that would allow a single hull to perform anti-submarine warfare, mine countermeasures, or surface combat. In practice, this vision failed to materialize. Mission modules were developed after the ships themselves, creating compatibility and reliability issues. Anti-submarine modules could not operate effectively due to hull-generated noise and wake interference. Mine countermeasure modules, critical in post-World War II naval strategy, were delayed, leaving the Navy without functional mine-hunting capabilities. Surface combat modules eventually became operational, but only after years of iterative fixes. Each shortcoming compounded the perception of LCS vessels as little crappy ships, unfit for their intended multi-mission roles. Crew strain and human costs. The human toll of these mechanical and design failures was severe. Sailors found themselves spending more time repairing ships than performing operational tasks. Many onboard systems were proprietary, requiring contractor intervention, further hampering the crew's ability to maintain readiness. Small crew sizes, initially intended to reduce operational costs, proved inadequate. Habitability issues forced sailors into shared bunks, creating additional stress during extended deployments. Leadership pressure exacerbated the situation, compelling crews to sail despite known deficiencies. The juxtaposition of high expectations and low functional capability created a persistent environment of tension, frustration, and operational risk. This sets the stage for the final decisive moments and program fallout in Climax. Section 2. The 2016 Operational Exposures. By 2016, repeated breakdowns revealed the LCS program's limits in stark terms. During Rim of the Pacific, RIMPAC, exercises and forward deployments to the Western Pacific, multiple vessels suffered severe propulsion failures mid-mission. Freedom-class ships experienced repeated combining gear malfunctions, forcing emergency returns to port. Independence-class trimarans cracked hulls under normal operational stress, highlighting the fragility of aluminum construction for high-speed naval operations. Water jet propulsion systems caused several navigational mishaps, including collisions with Panama Canal infrastructure and minor accidents at port, illustrating the inherent risks of these untested systems under realistic operational conditions. Pressure from Navy leadership. Top Navy commanders, including regional fleet leaders and senior admirals, pressed crews to maintain schedules despite evident mechanical issues. Operational readiness reports frequently cited unsafe conditions, but political and strategic pressures outweighed technical caution. Young officers faced intense pressure to succeed. Failure could stall careers, yet they were commanding vessels incapable of fulfilling their design specifications. The combination of inadequate crew training, complex proprietary systems, and leadership-driven operational demands created a perfect storm of risk, inefficiency, and embarrassment for the Navy. Programmatic mismanagement. The dual-class approach, Freedom-class monohulls in Wisconsin and Independence-class trimarans in Alabama, compounded problems. Each class required different maintenance protocols, unique training regimens, and separate mission module integration, preventing economies of scale and creating logistical complexity. The original plan to test 2 ships of each class and select a winner was abandoned. Instead, both classes were mass-produced, significantly increasing cost and operational risk. Congressional oversight revealed misestimated construction costs, which more than doubled initial projections, and a lifetime program, cost exceeding $100 billion. By 2016, the Navy possessed more LCS vessels than needed, yet none were fully operationally capable across all intended mission sets. The human and strategic impact. Sailors and officers described a paradoxical environment. Too few personnel to operate essential systems efficiently, yet too many proprietary and malfunctioning systems that required external contractors. The result was chronic operational downtime. High-profile failures garnered intense media attention, amplifying public scrutiny. ProPublica and other outlets highlighted the Navy's struggle, emphasizing that these ships, despite high speed and advanced modular design, often functioned more as logistical burdens than combat assets. By the close of 2016, it was clear that the Littoral Combat Ship program had reached its operational breaking point. The operational failures of the Littoral Combat Ships, LCS, forced the U.S. Navy to confront the gap between ambition and reality. By 2017, multiple Freedom-class and Independence-class vessels had already been sidelined due to mechanical failures, combined with the inability of modular mission packages to function as intended. High-speed propulsion systems, while impressive on paper, exacted a severe toll on hull integrity and engine reliability. The Navy faced a difficult question: retire these expensive vessels prematurely or continue investing in repairs that might never yield fully operational ships. Ultimately, leadership pursued a combination of both, initiating early decommissioning for some ships while attempting incremental fixes on others. Political and budgetary fallout. The political implications were significant. Congressional oversight hearings revealed that the LCS program had far exceeded its original budget, estimated at over $100 billion for 35 ships. Lawmakers criticized the Navy for prioritizing speed of delivery over combat capability, while Secretary of the Navy and top admirals faced scrutiny for pushing flawed vessels into deployment. Shipyards in Wisconsin and Alabama, tied to Freedom-class and Independence-class production respectively, relied heavily on the program for local employment, creating political pressure to continue construction despite operational shortcomings. This tension between strategic need and political economic considerations shaped the Navy's procurement decisions for years to come. Impact on crews and naval culture. The sailors assigned to these ships experienced a uniquely challenging environment. Many reported spending more time performing maintenance and troubleshooting contractor-controlled systems than executing actual missions. Crew sizes were insufficient for complex systems, forcing rotations and shared responsibilities that undermined efficiency and morale. Proprietary systems often prevented hands-on repairs, creating reliance on external contractors. This departure from traditional naval operations fostered frustration and fatigue among crews and highlighted a broader cultural issue. The Navy had designed a vessel technologically advanced, but operationally alien to the sailors expected to run it. Strategic and operational implications. Operationally, the Navy's capacity to perform mine hunting, anti-submarine, and surface warfare missions was compromised. LCS vessels were intended to replace aging frigates and minesweepers, providing a flexible, modular solution for littoral and nearshore engagements. Yet persistent mechanical failures and incomplete mission modules left the fleet with critical gaps. For example, with mines remaining a persistent threat to strategic ports and narrow waterways, the inability of LCS vessels to effectively conduct mine countermeasures posed a tangible risk to both naval and commercial shipping operations. Public and media perception. Public awareness of the program's failures intensified following investigative reports from outlets like ProPublica. Stories emphasized the disparity between cost and capability, coining the widely recognized nickname, "Little Crappy Ships." Media coverage framed the LCS program as emblematic of broader procurement and oversight failures, creating pressure for reform within both the Department of Defense and Congress. These narratives reinforced skepticism about future naval procurement programs, particularly those relying heavily on untested technologies and modular systems. Decommissioning and fleet adjustments. By the early 2020s, the Navy began the process of decommissioning several LCS vessels, some barely 5 years into service. Ships like the USS Sioux City, LCS-11, became emblematic of the program's missteps, commissioned with fanfare and community support, only to be retired prematurely. The decision to decommission early reflected both operational realities and budgetary constraints. Maintaining vessels with persistent mechanical issues and incomplete mission modules was financially unsustainable. The early retirement also revealed gaps in long-term fleet planning, as these ships had been intended to form the backbone of the Navy's small surface combatant force. Lessons in procurement and design. The LCS program illuminated critical weaknesses in U.S. naval procurement. First, the Navy's approach of designing ships before finalizing mission modules proved disastrous. Modular systems could not be retrofitted effectively. Second, simultaneous development of two distinct classes, the Monohull Freedom Class and Trimaran Independence Class. Complicated training, logistics, and maintenance, creating inefficiencies that would persist throughout the program. Finally, political and industrial pressures to keep shipyards employed contributed to overproduction and prevented timely course corrections, underscoring the delicate balance between national defense, economics, and politics. Operational lessons. Strategically, the Navy learned hard truths about the limitations of speed, range, and armament on modern warships. The LCS demonstrated that extreme high-speed designs could compromise structural integrity and reduce weapons and sensor capacity. Anti-submarine warfare and mine countermeasure missions were particularly impacted, as the vessels lacked the operational endurance and specialized equipment needed for sustained deployments. These deficiencies prompted a re-evaluation of future ship classes, leading to renewed interest in frigates and more robust multi-mission platforms, such as the Constellation-class frigates currently under construction. Impact on naval leadership. The LCS program also left a lasting imprint on naval leadership. Top commanders faced criticism for pushing ships into operational deployment before they were fully mission-ready, highlighting gaps in accountability and oversight. Congress and the Department of Defense undertook extensive hearings, emphasizing the need for stricter project management, realistic timelines, and more rigorous testing before deployment. Lessons learned from these failures have informed not only subsequent shipbuilding programs, but also broader defense acquisition reforms, including modular system testing, crew training, and lifecycle cost projections. Broader implications. Beyond the Navy, the LCS saga has had ripple effects across American shipbuilding and defense policy. Contractors and shipyards now face increased scrutiny when designing and building complex, modular vessels. Future programs are more likely to integrate full-scale testing, operational simulations, and iterative design processes to avoid repeating past mistakes. The LCS program, despite its flaws, has become a case study in the challenges of balancing innovation, budget, and operational readiness within the context of modern naval warfare. The story of the Littoral Combat Ship program is more than a tale of technical failure or bureaucratic missteps. It is a reflection of the complex intersection between ambition, innovation, and human decision-making in modern naval warfare. The Navy sought a new generation of vessels, fast, flexible, and modular, that could respond to the evolving threats of the 21st century. Yet, in pursuit of speed and versatility, critical trade-offs were made. Weaponry, range, survivability, and maintenance autonomy suffered. From a technological perspective, the LCS program underscores the risks inherent in pioneering untested concepts. Modular warfare, high-speed trimarans, and lean crews were all promising ideas on paper, but the execution revealed the gap between design theory and operational reality. Human factors amplified these challenges. Sailors and officers were pushed to operate vessels that often defied their capabilities, relying on contractors for critical systems and facing constant mechanical failures. Leadership pressures, political influences, and industrial incentives created a perfect storm where innovation became a liability rather than an advantage. Historically, the LCS serves as a cautionary example of how modern militaries must balance experimentation with realism. The lessons learned about planning, procurement, testing, and life cycle management will echo through future shipbuilding programs and inform how Navies worldwide approach modularity, speed, and multi-mission design. Ultimately, the LCS program reminds us that technological ambition must be tempered by operational practicality. Ships are more than steel and engines. They are floating embodiments of strategy, skill, and human endurance. While many of the littoral combat ships may now sit in reserve or scrapyards, their legacy endures as a symbol of both the promise and peril of trying to push naval warfare into the future too quickly, without the grounding of thorough, tested execution.